Hello, today we are going to begin covering lesson 4.5, solve quadratic equations. Your objective today is you guys will be able to solve quadratic equations by factoring. The first thing I want to point out is when it says to solve, that means instead of just having the polynomial here and factoring, we have it that it's equal to 0. Now it must equal 0. So if it does not, we need to solve. So first thing here, our quadratic must equal 0. It also might not say solve. There's a couple other words that we can use. It might say solve. It might say find zeros. It might say find roots. It might say find intercepts. Or even factor to solve. Okay? So these are all possible ways to say the same thing that we are going to do here. So, as it says, we are going to solve each equation by factoring. That just means start by factoring. Like we did before, we need factors. Of 36 that subtract to -5. So the factors of 36, there are a bunch of them. 1 and 36, 2 and 18, 4 and 9, and 6 and 6. If we notice, only one of these pairs, 4 and 5, can subtract to -5. So go ahead and put those within a parenthesis set. And then we need one of them to be negative and one to be positive. If we are subtracting to -5, we need to take 4 minus 9 and get -5. And then bring down the equals 0. From here, this is the only new part. To solve these, we just set each parenthesis equal to 0. So we solve for x on each of these, so x is going to equal 9. And x will equal -4. And then we have our solutions. Notice there are two solutions. Linears have one solution. Quadratics have two solutions. This is just, if I draw a sketch here, telling us where it crosses the y-x-axis. So if we drew it in, this is just a quick sketch, but if we drew it in, our parabola would cross at this point on the x's. That is why it's called find the intercepts, or find the zeros. That's why it can be called that as well. And that's it. So one extra step compared to last week's where we just set them equal to 0. This next problem, very similar, but this time it is not already equal to 0 for us. That just adds one little step. We go ahead and subtract 1 on both sides to get our right side equal to 0. Now I need factors of 42 that subtract to -1. So there's a lot of these. I'm going to go ahead and just skip right to the one that I know it is. You should be able to do this as well. I know 6 and 7 are factors of 42. If they need to subtract to -1, we'll have x minus 7 and x plus 6. Now I have the right side equal to 0, so I just equal that to 0. And now I go ahead and solve for each of these separately. So x equals 7 and x equals negative 6 are my two solutions. Notice you could draw a graph for this again. That's where this quadratic equation graph crosses the x-axis. All right, problem 3, also similar to problem 2. We don't have it equal to 0, so we need to subtract 10 on both sides. We get 3x squared plus x minus 10. Check for a greatest common factor, since there is an a value that's different than 1. There's not a greatest common factor, so we can go ahead and do the slip and slide method. So we slip it back, slip the 3 back, we get x squared plus x minus 30. Then we need factors of 30 that subtract to positive 1. So the factors of 30, there's a lot of them again. If you just look at your factors, I'm going to skip right to the one I know. I know 5 times 6 is 30. One of them will have to be negative. I know we need to get to positive 1, so I need positive 6, negative 5. And then I slip, or I slide, I guess I should say, my 3 under both terms. Reduce it if possible. If not, slip the 3 back up front of the x. If we were to check these by foiling, we would be back at our original problem. From here, we need to still have these equal to 0, so we set each of them equal to 0, x plus 2 equals 0, 3x minus 5 equals 0, and we solve x equals negative 2. This one we need to do 2 steps. We need to add 5 on both sides, 3x plus 5, and then we'll end up getting a fraction. Let me shrink this down a little bit. Then we divide by 3, and we end up getting x equals 5 over 3. That's totally fine. You could also write that as a decimal if you wanted to, but those are our 2 solutions. All right, last one of this type. Check for a greatest common factor. Turns out there is one. All of these terms can be divided by 3. So if we do that, we end up getting 3. And then inside parentheses, x squared minus 2x minus 3 equals 0. And then go ahead and factor the inside part. So we need factors of 3 that subtract to negative 2. 3 is pretty easy. There's only one factoring pair that you can have. So we'll just have to figure out the signs. We have 1 and 3. If we need to go to negative 2, we need the 3 to be negative. Equal that to 0. And then go ahead and solve. So x equals negative 1. And x equals positive 3. Once again, if we were to graph this, this is where it would cross the x-axis at negative 1 and positive 3. Oh, also, doesn't change our factor solutions anymore, but make sure to bring down this 3 that we pulled out. All right, these next ones, it's the same thing. Find the zeros by writing an intercept form. Instead of just having it equal to 0, they have it equal to y, but then you just know that the y has to be 0 to find the intercept. So basically just do the same thing. You're going to do factors of 12 that subtract to -1. I know we have quite a few factors of 12, 1 and 12, 2 and 6. 3 and 4, the only pair that can subtract to a -1 is 3 and 4. So we have x and x, 3 and 4. If we need a -1, the negative number needs to be the bigger number. And then we equal that to 0. And then we just go ahead and split them into 2 and finish solving. And we are done with that one already. Pretty simple. This one, we work it the same way. We need factors of 36 because there's no greatest common factor. We can't pull anything out. That add to 12. If you notice, there are a bunch of 36s, but the only set that can add to 12 is 6 and 6. So we have x plus 6, x plus 6. That can be written as x plus 6 squared. Now, it doesn't honestly make much of a difference. You take the square root of 0, you still get x plus 6 equals 0, and you solve. You're going to get that x equals -6 either way. And you can decide to write the factor or the 0 twice, but you don't have to. This just means that your vertex is going to be at that -6 point since it only crosses the axis, x-axis, one time. All right. Now we do have a second part to this. I will have a second video that you can watch.